Hi there. Let me take a few minutes and discuss some of the questions on the study guide over data types. So first of all, question one, data are collections of observations. Those collections could be, for instance, a set of GPAs for a particular class at our high school. It could be a collection of license plate numbers of randomly chosen cars driving down US 31. It's simply a collection of observations, and the observations are tied to particular individuals that are being studied. So, a population is the complete collection of all individuals to be studied. And something to think about, the individuals don't have to be people. Those individuals could be individual automobiles, they could be individual M&Ms, they could be individual orangutans. So, they don't have to be people. So the population in the Literary Digest poll was all adults that were eligible to vote in the 1936 US presidential election. So the poll itself didn't ask all adults, they were asking a group of all of the adults, but the actual population represents everyone that could have voted. And a census would be trying to collect data from every member of a population. The United States does a census every 10 years, and quite frankly, it's pretty difficult to try to, and in fact, impossible to actually contact every member of a population. But we take 10 years and try and do it. Fancier sounding word here, you don't need to use the word subcollection. A sample is a subcollection of members of a population. You could just say a part of a population, a piece of a population, that would be fine. And in number 6, yes, the Literary Digest poll was a sample. It was in fact a humongous sample. It was a sample of 10 million in theory eligible voters in the United States. It was a huge sample, but just a sample. I starred number 7 because number 7 represents the main idea here of this unit. So an important goal of statistics in general is to try and make a conclusion about a population. We usually can't survey or sample every member of a population, so we try to make a conclusion about some characteristic of the population by looking at that same characteristic of a sample or a piece of that population. So to accurately represent the entire population, one very important way of collecting data is to make sure that we're using random selection. So proceeding then, a parameter represents a characteristic of a population, whereas a statistic represents a characteristic of a sample. So notice the P's and the S's go together. Parameter describes population. Statistic describes sample, P, P, S, S. So let's switch over here to the second page. So on the second page, quantitative data are data consisting of numbers. So numeric data is another way of saying quantitative data. Counts or measurements. And quantitative data in particular should include the unit of measurement. So units are very important, as question number 11 demonstrated. The over $100 million Mars Climate Orbiter, it was lost because the programmers got confused between metric units and English units in some of the control software. So there goes the orbiter. Question number 12 then. There are two types of, if you will, quantitative or numeric data. That would be discrete or continuous data. So on my actual key here, I wrote answers that are pretty formal. Let me make sure that I can give you the main idea between what discrete and continuous mean. Discrete data are simply countable options. So for instance, let's say the number of cylinders that an automobile engine may contain. So most automobile engines have 3 cylinders or 4 cylinders, 5 cylinders, 6 cylinders, 8, 10, or 12. I can actually count them. You can't have 2.5 cylinders. You can't have 2.673 repeating cylinders. There are a particular number of options, and I can count them. Whereas continuous data is different. It can be represented by infinitely many options within some particular interval. So for instance, if you're measuring someone's height, someone may claim to be 5 feet 8 inches tall, but they might really be 5 feet 8 1/3 inches tall. Maybe that's really 5 feet and 8.326 inches tall. So there are infinitely many options. That's continuous data. So another type of data that we can collect is called categorical data. And literally, just like the name implies, categories, names or labels. Data, and very important data, can consist of names or labels. For instance, we might be trying to categorize all of the subjects in our sample by hair color or by eye color. Even things that sometimes you think of as numeric data. For instance, you could be in grade 9, 10, 11, or 12. So we could classify every student in the population at Westfield High School as being in grade 9, 10, 11, or 12. But really, the 9, 10, 11, and 12 are simply labels. We could also call them freshmen, sophomore, juniors, and seniors. So categorical data represents a name or a label, whereas quantitative data, the top of the second page, is numeric data. So the homework assignment then relies on actually exercising these definitions. And the best way to understand the difference between discrete and continuous data, between quantitative and categorical data, is to actually look at specific examples in context and see if you can identify and match up the appropriate definitions. That's what the assignment does. Hope it's been helpful to go through this study guide.